Hey friends, today we're going to talk about radical form versus rational exponent form. So our central question is going to be, how can you differentiate and move between radical form and rational exponent form? So before I dive into this, I want to make sure that you actually do remember what it means for something to be a radical and what it means for something to be rational. So radical form. A radical is just a fancy way of saying a square root symbol. So if there is a square root symbol, that could also be read as radical of 4. Okay, so this symbol here, not the radical of 4, but this symbol right here is a radical. The 4 itself is what we call the radicand. So the radicand is whatever is underneath the radical. So it could be a number, could be a variable, we could have an x under here as well. Then that x would be a part of that radicand. Okay, so the radical is the symbol itself. The radicand is the number or variable or whatever expression is underneath the radical. To be rational, all that means is that it can be written as a fraction. Can be written as a fraction. Okay, and exponent, hopefully you remember that exponent is a number up top. So if we're looking at an example here, say we have something like 2 to the 1/5. Okay, 2 is what we call the base, and 1/5 would be the exponent. Now this is a rational, which is highlighted in green. This is a rational exponent because it is an exponent that is written as a fraction. This is a very brief introduction to get some of the vocabulary down for what we will be discussing later. Okay, so I have several different examples here of radicals or numbers, variables that are in a part of a radical expression. What we're going to do is we're going to learn how to take these radical expressions and write them in rational exponent form. So we're starting off with them in radical form. Our end goal is to be able to write them in rational exponent form. So again, just a quick recap. This little symbol right here is what we call the radical. Okay. The number underneath is what we call the radicand. Radicand. My pen's not working. This was a radical. So I reviewed that on the first slide. The other thing I want to show you is this little number right here, which there's nothing here right now. When there's nothing there, we just say square root, so we know that's a 2. That number is what we call the index. Okay, my pen's not working out. There we go. That's what we call the index. So you can take all of these and write them in rational exponent form. So the square root of 2, if we take that and write that as rational exponent form, that's going to become 2. Actually, let me use green for the color scheme. And then my index here was 2. So that's my denominator. My numerator is whatever my exponent was in the radicand. So in this case, it's going to be 1. In the radicand here, if there's no exponent, we know that there's really a 1 there. So when you take a radical form and write it as an exponent form, the numerator of your exponent is whatever the exponent was from the radical. and the denominator is whatever your index was from the radical form. Okay, so again, this first one, my index was 2, so my denominator of my exponent in rational exponent form is 2. The exponent on the radicand was 1, so my numerator in that exponent is 1. So let's take another look here. On this next example, we have the cube root of 4. So my index is 3. My radicand is 4. The exponent on my radicand is 1. So when I take this and write it in rational exponent form, my radicand comes over, so that's just 4. My exponent was 1, and my index was 3. So this will become 4 to the 1/3. Let's try one that has a little bit more going on. Okay, so in this third example, my index is 8. My radicand is 3x. They're both a part of that radicand because they're both underneath the radical symbol. The exponents on both of these guys are 1. Okay? So when we take that over, we are taking the entire radicand. So my entire radicand is 3x. So I'm going to put it in parentheses so I know the entire thing is coming over. The exponent on that entire thing was 1. So my numerator of the rational exponent is 1. My index for that entire thing was 8. So it's going to be over 8. So we write this as the quantity of 3x to the 1/8 power. All right, let's talk about one more. Okay, so in this last one, my index is 7. My radicand is x, and my exponent is 2. Okay, so when we bring this into rational exponent form, we take the radicand, which is x. The exponent is currently 2, so that's the numerator of my rational exponent, and the index is 7. So this will be written as x to the 2/7 power, or x to the 2/7 power. All right, so here we have 4 for you to try. So I would pause the video, give each of these a shot. You can just do it on scrap paper or whatever you have handy, and then come back in and see how they went for you. Okay, so hopefully for number 1, you were able to get 3 to the 1/2 power. For number 2, 2 to the 1/4 power. For number 3, the quantity of 8x to the 1/9 power. Remember, without those exponents, that would be incorrect. And for number 4, x to the 2/3 power. I also want to talk a little bit about how to simplify expressions that do have rational exponents. So I'm going to start by giving you an expression that is in rational exponent form. So the first one we have here is 16 to the 1/2. I know this is in rational exponent form because I have an exponent here that is a fraction. So that is indeed a rational exponent. So think about what we started with today. We started in radical form today. So you may remember that if your exponent is 1/2, that's the same thing as having the square root of 16. So our index is 2, but remember, we don't really need to write that. So the square root of 16. That should look a little bit more familiar to you. Hopefully you know that the square root of 16 is 4. So if you were asked to simplify 16 to the 1/2, that would be equivalent to 4. So I'm going to use a similar expression here, but a little bit different. So in this next one, we have 16 to the 3/2. So again, this is in rational exponent form because you do have an exponent that is a fraction. So I'm going to kind of break this down a little bit. We knew that 16 to the 1/2 was the same as the square root of 16. So this is really the same thing as having 16 to the 1/2, but you have that 3 times if you think about exponent rules, because 1/2 times 3 is 3/2. Okay, so we know that 16 to the 1/2, this is square root of 16, is 4 from above. So really this is 4 to the 3rd power, and 4 to the 3rd power is 64. And you can use your calculator to check that. Let's look at another example. We do have an expression in rational exponent form. We've got this rational exponent here of 1/5, that is a fraction. Okay, so really that is the same thing in radical form as if you had the 5th root of 32. So basically you're asking yourself what times itself 5 times gets you to 32. So you may know that one. If not, you can use the calculator. That will equal 2. Okay, so again, another one that's similar to that. This is in rational exponent form because you have a exponent that is a fraction, so it's -3/5. So I'm going to think about that, what we were given up top. That's the same thing as if we have 32 to the 1/5. Then all of that to the -3. Okay, so from above, we know that 32 to the 1/5 is 2. Then we still have that -3. So you may remember that negative exponents are not allowed. That means there's a negative attitude, and negative attitudes get kicked out. So this really comes to the denominator. And then 2 to the 3rd is 8. So this is the same thing as 1/8. So there's a little bit of simplifying expressions with rational exponents. Feel free to reach out to us if you need help with anything. We are going to do a little Quizlet matching activity just to practice matching before you do your self-check. So there is a self-check in Schoology for you to do today. And then there is a Get More Math assignment, which addresses the latter part of today's lesson. Thanks, guys. Have a great day.